Hello, welcome to Pre-Cal Lecture 3.1, where we're going to be talking about relationships between 2 points. So you'll be taking notes on your own paper this time. And 3.1.1, we're going to talk about the distance formula. So let's go ahead and draw an X and Y coordinate plane here. So I'm going to mark some points here. We're going to call this Y1 and Y2. And then we're going to mark a couple of points on the x-axis, X1 and X2. So I'm going to draw a point at X1, Y1 and also one at X2, Y2. And we will connect those 2 points with a line. We're going to call that the length of that line D. Okay, so what we can do here is make ourselves a right triangle. And the distance of the base of this right triangle, the length of it, is x2 minus x1. And this leg of the triangle that goes north and south, the length of that would be y2 minus y1. So the question is, what is the distance between these 2 points? Okay, well, if we use the Pythagorean theorem, we could say that d squared, hypotenuse squared, d is just the hypotenuse, is equal to x2 minus x1 all squared, so the one leg of the right triangle. So c squared is a squared plus b squared, right? So plus y2 minus y1, the length of the north and south leg, all squared. So if we take the square root of both sides, then our distance formula becomes the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, just the Pythagorean theorem. All right, so let's do an example here. So excuse me there. The question is, find the distance between the points six, 4. So this is just points on a graph. X is 6, y is 4, and -8, 11. Okay, so if we want, we could call this 6x1 and the 4y1. The -8 could be x2 and the 11 could be y2. Or you could reverse that and put the 2's over here and the 1's over here. It doesn't really matter because we're going to square it. So when you square a negative, it becomes positive. So everything works out in the end. Okay, so the distance between those 2 points is going to be the square root of the distance between the two x's. So 6, I guess the way our formula is, we would have the x2 first, but it really doesn't matter. But -8 minus 6 all squared plus 11 minus 4, all squared. All right, so that's going to be the square root of negative 14 squared plus 7 squared, which would be the square root of 196 plus 49. And you wouldn't have to show this much work. And that is equal to the square root of 245, which is totally fine. Or you could put it in your calculator, and that'd be 15.65. So the distance between those 2 points is 15.65. And again, if you do it x1 minus x2, y1 minus y2, it's not going to mess things up, because when you square the number, it'll make it positive. Okay, so that's the distance formula. You have several on your worksheet for that. So the next topic, 3.1.2, is called the midpoint formula. Okay, once again, we're going to draw an XY coordinate plane. We'll have 2 points again, y1 on the y-axis, y2, x1, x2. Go ahead and put a point there, connect with a line. And this time what we want to know is what are the coordinates of the midpoint of that section of line. Okay, well, the formula is this. And it's not a really hard formula to memorize. So we would have the x midpoint is x1 plus x2 over 2. We'll call this x sub m. And y sub m is y1 plus y2 over 2. You might have been able to guess that formula yourself, but you do have to memorize that formula. So let's do an example. So we want to find the midpoint of 1, -1, and 5, 5. Okay, sometimes it's safe to just mark the x's and the y's. So that's x1, y1, x2, y2, because I've had students accidentally kind of put the x's and the y's together. Okay, so x midpoint is going to equal to 1 plus 5 over 2. So that's 6 over 2, which is 3. And then the y midpoint is -1 plus 5 over 2, which would be 4 over 2, which is 2. So the answer, and you have to do it in turn, you have to give your answer in the form of a point on the coordinate plane, would be 3, 2. Now in your homework you're going to have fractions you have to deal with. That's fine. Just deal with the fractions. All right, so that does it for section 3.1. Let's go to 3.2. And all of this should be review from algebra. Could even be algebra 1. So section 3.2 is called graphing important functions. Actually, I'm not going to, we'll get to that in 3.3. I apologize, erase that. 3.2.1, we're going to just call circles. So all points on a circle are equidistant have an equal distance from the center. Okay, so let's do an XY coordinate plane again. And we will draw ourselves a circle. All right, it's not a very good one, but that's okay. So we're going to mark a point on the circle XY. All right, and then I'm going to have a center of the circle right there. We're going to call that HK. All right, so I kind of smushed all this in pretty bad. Hopefully you can do a better job. Let's put the center of the circle out away from the line just a little bit. So we'll call that HK. Okay, so the X value is H, and this X value is X, and that center value is K, and then we have a Y up here. Okay, so this distance from the center of the circle to the point on the circle is called R. So R is equal to the radius. And R can be computed by the distance formula. Okay, because we can make that into just a right triangle. Okay, so R, and you're going to want to memorize this, R is equal to the square root of X minus H. That base, that length from here to here is X minus H. So X minus H all squared plus the north to south distance for that leg of the triangle, right? So that's going to be Y, which is Y, minus K, all squared. So if we square both sides, and we get the standard equation for a circle. So the standard equation for the circle, which you do need to memorize this as well, is just square both sides. R squared is equal to X minus H all squared plus Y minus K all squared, where the point HK is the center and xy is a point on the circle. Okay, so you need to know the standard of equation for a circle. Know that HK is the center and XY is the point on the circle. And I will give, you can pause the video if you want, so you can, if you're not finished writing this down yet, but I'm going to have to erase all this, and we will work some examples, and then we'll be done with this lecture. So here we go. Okay, so just to remind you, for a circle R, the radius is equal to the square root of x minus h all squared plus y minus k all squared, where xy is a point on the circle and HK is the center. And then the equation for the circle, standard equation, is r squared is equal to x minus h all squared plus y minus k all squared. Okay. So let's work a couple of examples here. Find the equation of a circle with radius 5 and centered at -2, 3. Okay. This is pretty easy. We're just going to plug these numbers into the standard equation of the circle. This would be h, and this would be k. All right, so it would be 5 squared is equal to x minus -2, that's h, x minus h all squared, plus y minus 3 all squared. So that's going to be 25 is equal to x plus 2 all squared, x minus -2, two negatives make a plus y minus 3 all squared. All right. Let me do a little side note. If the center is at the origin, or so at 0, 0, the equation becomes r squared is equal to x squared plus y squared. So that's only if it's centered at the origin. You may have seen that before. Sometimes when teachers are teaching about circles, they just start with the center at the origin. Okay, last example. Write the equation of a circle with center 1, -2, and a point on the circle is 5, negative 2. Okay, so first of all, we need to get the radius. So with the center, so this is going to be h, this is k, and this would be x and y. It helps sometimes to label everything. Okay, so first of all, let's get the radius. So we have an equation for the radius right up here. Except this time we have x and y, so we can figure out the radius numerically. It's going to be the square root of x minus h. So 5 minus 1 all squared plus y minus k. Well, what is y? Negative 2 minus negative 2 all squared. Well, that's going to be 0. Negative 2 plus 2, that's 0. So this would be 4 squared. Square root of 16, which is 4. So we have a radius of 4. So now we can write the standard equation for the circle. That's going to be right here. Plug it in. R squared, so 4 squared is equal to x minus h, x minus 1 all squared plus y minus k minus negative 2 all squared. So let's clean that up a little bit. That's going to be 16 is equal to x minus 1 all squared plus y plus 2 all squared. Now, a way to quickly figure out the center would be the number that is next to x, change the sign, and that's the x value. The number that's next to y, change the sign, and that's the y value. Okay, so see how they're like that. All right, so your homework is... erase some of this here. Is worksheet 3.1, 3.2. And you're going to be having to deal with some fractions there. All right, so we'll see how good you are at dealing with fractions. We did that before. Don't panic. Just deal with the fractions, and we'll see how you do. I'll talk to you on the next one.